A lot of people, including astronomers, don't really grasp what the universe is. It's hard to grasp the size of it, it's hard to grasp the shape of it. A lot of people might just imagine it as a sphere, but it's not. It doesn't, you don't go to the edge and then there's something outside that. You know, there's theoretically nothing outside that, and nothing isn't just blank space. That is something. Nothing is sheer nothingness, and that's impossible to comprehend. So. It's a form of time travel. People say time travel is not possible, but you can look into the past. And that's what we're doing when we look at the night sky, especially with deep field imaging, like looking right as far away from the Earth as you can possibly do into the universe. You're looking at early galaxies, galaxies that formed long before our galaxy. And you're looking at what the universe looked like earlier on in its life. Everything you look at in the night sky, it took time for the light to travel from there to here. So from the moon, it takes 2 seconds. It takes 8 minutes for the light to get from our sun to there. And then when you take it out further to the next stars, we're talking on the order of years. The closest star, something on the order of 3 or 4 or 5 years. There's telescopes in the Canary Islands that are automated, and they search for planets around other stars. And then we use this telescope to look at some of the stars that have been flagged up as possible planet hosts. And we can use this telescope to look at that star over the course of the night and determine whether the object that's orbiting around it is indeed something that might be a planet. And that's brilliant, you know, the confirmation of a planet from sea level in Scotland is spectacular with a 50-year-old telescope. Since I was young, I just wondered, you know, what is this? What's going on? Like, okay, it doesn't seem to affect some people as much as it does others, but it really hit me. I just wanted to know why I was here, what the Earth was doing there, what was in the rest of space, and just what the whole thing was, and to see if I could understand, like, just what the hell is going on, you know? What is all of this?
Okay, I think as any scientist is, we're driven by the unknown. That's the one thing that we're all desperate to try and uncover and to bring into the light.
The Kepler ones and the WASP ones, the stars didn't have a name before, right?
Yeah,
so they're naming them when, but they didn't even have
we're interested more in trying to place ourselves in context and try to understand where we come from and what it all means. I think we all share that big problem. It is the biggest problem. It's the ultimate piece of context to put us in, to help us understand who we are and why we're here. I think it's one of the most important things that we can do as a species is try to figure out the answers to this biggest question, the question that all scientists and to some extent all human beings are trying to answer. My work is split into several parts, all of which are theoretical. And the first part is trying to understand more about how you go from a very early solar system where you have a very young star and a disk of dust and gas around it, how you go from that stage to a stage where that disk of dust and gas has coalesced into planets and you have a planetary system like ours. That's one sort of key part of my work, if you like. And the other part is looking at the much more advanced stage where you have your planets and you have your stars, and you're looking at possibly how life itself could form on those planets.
So the study of exoplanets is an excellent resource to figure out more about the perspective that we can place on ourselves and say, what does it mean to be a human being? Is it a really unique experience, or will it be similar to other experiences that we could find elsewhere in the galaxy?
So
we start to learn more about our own planet. We start to piece together clues about how it may have formed. We start to make progress into answering the questions as to why this particular planet produced living organisms, which then went on to evolve and grow into ourselves. In some ways, we're looking upwards, but at the same time, we're looking downwards and we're looking inwards and learning more about how we function as human beings, how the planet functions.
I think the chances of discovering a planet that is habitable, they're very good. The first planet around a solar-like star, around a sun-like star, was discovered in 1995. It's now only 2012. It really is one of the youngest fields in astronomy, and at the end of last year, we had the first reports of what we're now starting to call Earth analog planets, maybe Earth mass, the possibility of a planet that is Earth mass. So now we're now down to almost finding planets in the same distance from their star with the same mass as Earth. And I don't think, personally, it's going to be a long time before the first possibly habitable planet is announced, which is quite exciting. you.